to touch on the concept of remainder and factor theorem, so we'll do both side by side together. Let's start with remainder theorem. Okay, we have a polynomial divided by this divisor here. So you realize that the x squared is missing, right? So I put as a 0 x squared. So now when I divide this expression, this dividend here with x minus 2, the question is, what is the remainder? All right, so what we have covered earlier on is we use something called the long division to find the remainder, right? So I will have x squared, and this will give us x cubed minus 2x squared. We subtract, that will give us 2x squared minus 5x. So I will need to multiply by another 2x to give us 2x squared minus 4x. Okay, and finally, I will have minus x plus 1. And I will have to minus 1 here, because that will give us minus x plus 2. After I subtract, the remainder is negative 1. So it's a very, very long process, right? Now, the beauty of the remainder factor theorem is I can actually do it in less than 30 seconds. Okay, so how we do that is, now we let fx be equals to x cubed minus 5x plus 1. And I want to divide by x minus 2. So I will sub in the value 2 here. Okay, I will explain why later. That will give us 2 cubed minus 5 times 2 plus 1, 8 minus 10 plus 1, negative 2 plus 1, negative 1. Then I got the remainder immediately. So the question is, how come I can sub in 2 here in order to get the remainder? All right, so this is the remainder theorem. The remainder theorem says that if this is the dividend, remember we use dividend equals to the divisor times the quotient. Okay, I will not write the quotient up. I know the quotient is x squared plus 2x minus 1, but that's not important because I don't want to do long division. Plus the remainder. And I put the remainder here. I know the dividend from the question. I know the divisor from the question, right? I do not need to know the quotient. I can find the remainder straight away. Now, what must I sub in here in order to make this part disappear? 2, right? Which is why I choose the number 2. So I sub in 2 here. I sub in 2 here. And this part will disappear. What is left? R2, right? Rx. So what's the remainder? The remainder is negative 1. If I have a function here and I divide by ax plus b, what can I sub in here in order to find the remainder? No, we let ax plus b equals to 0. Bring over ax equals to negative b, x equals to negative b over a, right? If we sub in negative b over a, we will get the remainder. Okay, that's the theorem. So now I will have 3x cubed. Let me do it a bit quickly. This one, the long division, you are quite familiar already. So I will plus 3x cubed. Then I will get minus, okay, because you minus this, I'll get minus 2x cubed. So I will minus 2x squared. Then I'll get minus 2x cubed again, minus 2x squared, minus once more, I'll get x squared, bring down, plus 3x. So I will plus x, then I'll get x squared plus x minus again, I'll get 2x plus 2, bring down, okay? And I will plus a 2 here. What's the remainder? The remainder is 0. Now, what do you know about the divisor? When after you divide by the divisor, you get 0. What's so special about the divisor? Let's take a number 12 here, right? When I use 12 and I divide by 2, what do I get? 6. What's the remainder? 0. Okay, again. I divide by 3. What do I put here? 4, right? What's the remainder? 0. I divide by 4. What do I put here? For the quotient, 3. What's the remainder? 0. And so on. What's so special about this divisor? If my remainder is 0. Yeah, can you see that 4, 2, and 3 are factors of 12? So when the remainder is 0, we can say what? We can say that x plus 1 is a factor of the expression there. So let's summarize. Okay, now when the remainder equals to 0, what does it mean? It means that x plus 1 is a factor of this expression here. Why? Because, back to that concept again, just now we say that given this expression here, we can express in terms of the divisor times the quotient plus the remainder. What number do I sub in order to remove this part here? What number do I sub in? -1, right? So I sub in -1. I will get 3. Sub in -1. Sub in -1. Again, -1. What do I get? You get 0, right? Okay, so the remainder is 0. And what does that tell us? If the remainder is 0, x plus 1 is a factor. So, to summarize, if the remainder is 0, we call this the factor theorem. The divisor is a factor. If the remainder is not 0, it's called the remainder theorem. The number there is the remainder. And this is not a factor. It gives us a remainder. All right, so that's the remainder and factor theorem. All right, that's it. Okay, then